Welcome to qnawire.
To have two forces, F1 and F2. F1 is going to be 200 newtons, 25 degrees south of east. So this is going to mean that in a current diagram, in which we're going to have north, south, east, and west, the first force is going to be at an angle of 20 degrees going down with a magnitude of 200 newtons. This is going to be force 1. Next up, force 2 is going to be 15 degrees north of east. North of east, and we're going to get that this is going to have a 130 Newton component. So to have it in a proper diagram, what we want to know is going to be the x component on one, the y component on the first one, and we're going to do the same thing for force 2. So for force 1, the x component is going to be equal to 200 times cosine of 20 degrees. The y component, as you can see, it's going to be negative, would be minus 200 sine of 20 degrees. And for the force 2, the x component would be 130 cosine of 15 degrees in this case. And the y component, it is going to be now positive, as you can see from our diagram, would be 130 times sine of 50 degrees. So the results are going to be 187.94. On the first one, I'm going to take everything to 5 significant digits. The other one is going to be 68.40, well, 0.404 newtons to 4040 newtons to keep to 5 significant digits, 404. The next one, or it's going to be 130 cosine of 50, 125.57 newtons. And the last one would be 130 sine of 15, 13.646. With this information, we can plot directly in our graph what is going to be the diagrams for F1 and F2. This is going to make things a little bit easier. Now, what we want to get is the resultant force. The resulting force is going to be the sum of F1 plus F2. And this is going to be equal to F1 on X plus F2 on X. All of this on the y-axis. Sorry, over here I missed a minus. Plus F1 on Y plus F2 on Y on the y-axis, which is represented by the J unit vector. So the resultant force is going to be, let's add up 125.57. Let's add these guys up. This is going to be 313.51 on the y-axis. On the other hand, we're going to get minus 68.404 plus 33.646, giving us minus 34.758 on the y-axis. And this is going to be our resulting force. The equilibrium force is going to be the one that is going to make things equal to 0. So the equilibrium force is going to have the same values, but with the sign change. And with this information, we can already do our sketches. Let me just write down F1 and F2 on the same representation just to make things easier when we want to write it down. So F1 would be 187.84 on the y-axis minus 68.404 on the y-axis, and force 2 was equal to 125.57 on I plus 33.646 on the y-axis. So with all of these plots, what we can do is get them direct. Sorry, with all of these vectors, what we can do is plot them in our xy Cartesian coordinate system, and we're going to get the results for each of them. So over here, of course, I cannot make it like properly, but you can do it with proper graph paper. And essentially, F1 is going to be 180. Let me make it bigger. Sorry, I took a while just to get the correct thing over here. So the actual plot would correspond over here. This would be F1, F2, the resultant, and the equilibrium force. And that would be all. Thank you very much, and have a good one.